Serial. The legacy of the serial port, an in-depth technical analysis. In the field of computer hardware and IT certification standards, the word serial usually refers to the recommended standard 232 interface, commonly known as RS-232. While the Universal Serial Bus, or USB, has largely replaced this technology for everyday consumer devices like mice and keyboards, the traditional serial port remains an indispensable tool for network engineers, system administrators, and industrial technicians. It serves as the primary language of last resort for configuring enterprise-grade hardware. It provides a direct, low-level communication link that remains functional even when a device's entire operating system or network interface has suffered a total failure. The fundamental concept, serial versus parallel. To truly understand the serial port, we must contrast it with its old rival, the parallel port. In a parallel connection, multiple bits of data are sent simultaneously across multiple wires. You can visualize this as an 8-lane highway where 8 cars can drive side by side. While this sounds faster on paper, it creates a physical problem called signal skew. At high speeds or over long distances, the electrical pulses in the different wires can arrive at slightly different times due to tiny differences in the wire length or electrical resistance. This causes the message to become scrambled and unreadable. A serial connection, by contrast, is a single-lane road. Data is sent one bit at a time, one after the other in a long chain. Because there is only one data path for the signal, there is absolutely no risk of bits arriving out of sync. This architectural simplicity allows serial cables to be much longer than parallel cables. While a parallel cable might fail after just 15 feet, a high-quality serial cable can often reach distances of 50 feet or more while maintaining a perfectly stable connection. While serial was historically perceived as slower in terms of raw bits per second, its inherent reliability made it the global standard for early modems and professional diagnostic equipment. The physical interface, DB9 and DB25. The most recognizable physical form of the serial port is the DB9 connector. Despite the letter D in the name, it is technically an E-type shell, which means its scientific name is actually DE9, but the entire computer industry almost universally calls it DB9. It is a D-shaped connector with 9 pins arranged in 2 distinct rows, with 5 pins on the top and 4 on the bottom. In this 9-pin layout, 3 specific pins do almost all of the heavy lifting. Pin number 2 is the receive data line, where the computer listens for incoming messages. Pin number 3 is the transmit data line, where the computer talks or sends its own data out. Pin number 5 is the signal ground, which acts as the electrical reference point to ensure the signals are measured accurately. In the early decades of computing, you might also encounter the larger DB25 connector, which features 25 pins. While it looks much bigger, it uses the exact same RS-232 logic and signals as the smaller version. In modern times, native 9-pin ports have disappeared from laptops, so technicians now rely on USB to serial adapters to bridge the gap between modern computers and legacy hardware. Communication parameters, baud rate and handshaking. Unlike modern USB devices, which are plug and play and configure themselves automatically, a serial connection is manual and unforgiving. Both the talking device and the listening device must be configured with the exact same mathematical settings before they can understand each other. If even one setting is mismatched, the text appearing on the technician's screen will look like a chaotic mess of garbled symbols and squares. The first setting is the baud rate. This is the speed of the connection, measured in bits per second. Common industry speeds include 9600, 38400, or 115,200 baud. You can think of this as the speed limit of the road. If the router is talking at 9600, but your computer is listening at a different speed, the data pulses will arrive too fast or too slow to be decoded. The second set of settings includes data bits, parity, and stop bits. These define how each chunk of data is packaged. A standard configuration used across the world is known as 8N1. This stands for 8 data bits, no parity for error checking, and one stop bit to signal the end of a character. Finally, there is flow control, also known as handshaking. Because a fast computer can sometimes send data much faster than an old router can process it, handshaking is used to tell the other side to pause or resume. Hardware flow control uses physical wires to send these signals, while software flow control sends hidden special characters directly inside the data stream to manage the traffic. The technician's essential tool, the console port. For a modern IT professional, the serial port is most commonly used as a console port for high-end routers, switches, and firewalls. When a piece of network equipment is brand new and has no IP address, it is impossible to reach it over the network or the internet. The only way to set it up is to connect a specialized serial cable, often called a rollover cable or a console cable. One end plugs into your laptop, and the other plugs into the port labeled console on the back of the device. This creates what is called a terminal session. This session provides a text-only command line interface directly into the hardware's brain. Because this connection is out of band, meaning it does not rely on the network being functional, it is the only way to recover a device that has crashed or has had its network configuration accidentally wiped by a mistake. Modern variants, SATA and SAS. It is important to note that while the term serial port usually refers to the old 9-pin connector, the core concept of serial communication is actually the foundation of our fastest modern storage technology. Serial AT attachment, or SATA, replaced the old flat ribbon cables used for hard drives. By switching from a parallel design to a serial design, SATA was able to reach much higher speeds of 6 gigabits per second without the signal skew issues that limited older drives. Similarly, serial-attached SCSI, or SAS, is the enterprise version used in high-performance servers. Even the fastest technologies we use today, like PCI Express and USB-C, are serial technologies at their heart. The industry moved away from parallel wiring because sending bits one by one at extremely high frequencies is ultimately more efficient than trying to keep dozens of parallel wires perfectly synchronized. Troubleshooting the serial connection. When a serial connection fails to show text, a technician follows a specific hierarchy of checks. First, they check the COM port assignment in the computer's device manager to ensure the software is looking at the correct physical adapter. Second, they verify that the baud rate and 8N1 settings match the device exactly. Finally, they might use a null modem adapter. Sometimes, you are trying to connect two devices that are both trying to talk on pin 3 and listen on pin 2. Because they are both talking into each other's mouths, they cannot hear anything. A null modem adapter physically crosses the wires inside the plug so that the talker on one side is connected to the listener on the other side, allowing the conversation to begin.